Assalamualaikum students, how are you? I'm your teacher, Sir Asher. You know very well I'm your physics teacher. I hope you will be great at your home and you are doing the study and you are learning the learning process going on at your home. So today again I will gonna repeat the my last lecture. So I'm gonna give you some recap about my last lecture about the I last time I told you what is the machine anything which is useful to a man, to human being to do the work easily. This is called the machine. So right now, efforts, the force applied on the machine is called effort. The load machine is lifted some kind of weight or overcomes any resistance is called the load. Input, the button on the machine is called input, and output, the button by the machine is called output. Mechanical advantage, last time I gave you, mechanical advantage is the ratio between the load and effort. It doesn't have any unit because it is a ratio. Right now we are talking about the efficiency. Efficiency, useful work done by the machine, work done on the machine. It means that efficiency is also the ratio between the work done, between the useful work done by the machine and the work done on the machine. It means that we can say useful work done by the machine is called output. You know very well. Work done on the machine is called input. Output formula of output W and H. H, this is the formula. W means load. H, the object, the force applied by the machine on the object to lift, to move, or to overcome the resistance. Input is equal to P multiplied by T. P is the effort is applied on the board. P is the effort applied on the machine, and D is the distance during the application of effort. The machine covers some distance D. So output W H we know very well, and input is P B is the input. Efficiency in the real case, no machine has 100% efficiency. Always the efficiency of a real machine is less than 1. But we are talking about the ideal machine. For the ideal machine, the efficiency of the ideal machine is 100%. So always we consider the efficiency of the machine in percentage like the result. So always, for example, your machine, the efficiency of your machine is 90%, it is not 100% in the real case. 70%, 40%, 60%. So for the ideal case, the efficiency of the machine is 100%. It means the efficiency is 1. Suppose that input is equal to 1. Output and input is equal to 1. It means that here input is divided when you should on the other side it will multiply by 1. So output is equal to input. It means that whatever work you have done on the machine, same work have done by the machine. No loss of energy. It means that you are applying the energy. The same energy is using completely in the work done by the machine. No loss of energy. This is not possible in the real case. For example, around you there are a lot of machines. So, but in real case, 100% efficiency is not possible. Less than 1 efficiency for the real case. Students, now we are going to tell you about the simple machine. For example, the first simple machine is lever. Lever is a simple machine which is used to lift the heavy weight by application of a small force, for a small effort. You can say we are applying the small effort, but we are lifting the heavy load. So here we are using the lever. Lever is a rigid bar. What definition? According to the definition, lever is a rigid bar which may be wooden or metallic bar which can rotate about a fixed point. This fixed point is called fulcrum. It means that Lever can rotate about a point. This point is called fulcrum. On the one side we apply the effort, and other side we apply. Other side the lever lifts the weight. The distance between the effort and the fulcrum is called effort arm, and distance between the fulcrum and the load is called load arm. And fulcrum is a midpoint. You can say there are fulcrum and effort and load. According to the kinds of the lever, they may be changed. Sometimes fulcrum in the mid, sometimes on the corner, sometimes the effort lies in the mid, and sometimes load lies in the load. The load lies in mid. It depends on the kinds of the lever. Look at here the figures over here in front of you. There is a figure. Look at here. This is the bar, rigid bar, and this is the which can rotate. This can rotate around about a fixed point. This point is called fulcrum, and this is the effort arm because it is lifting the load. This is a load, and this is the effort we are applying here. The distance between the fulcrum and the effort is called effort arm or power arm. Usually we use effort arm. You can also call it the power arm. The distance between the weight and the fulcrum is called weight arm or load arm. So this is the simplest form of the lever. For example, over here is a marker. Marker is rotating over here. This point, about my thumb is rotating. This is my thumb is fulcrum. Effort we are applying over here, and it is lifting the load on the other side. So this is a simple, you can say, lever is a simple or rigid bar which may be the made of iron or wooden. Now we are talking about the kinds of the lever. The kinds of the lever depends on the position, on the effort, load, and the fulcrum. For example, in first kind, we are talking about the lever of first kind. In first kind of lever, fulcrum lies between the weight and between the load and effort. Look at here the figure over here. This is the first kind of lever. Fulcrum, this bar is rotating about it. This is the fulcrum. Load, effort is applying on the other one side, and the load is lifting on the other side. This is the first kind of lever. What's the definition of the first kind of lever? First definition of the first kind of lever in which the fulcrum lies between the effort and the load. Now, real examples of the first kind of lever. Arm balance is the first kind of lever. A pair of scissors is also the first kind of lever. Seesaw, the kids play on it. Seesaw is the first kind of lever. Up now you are thinking about how can you say a pair of scissors is a lever, because there are two kind of bar. Absolutely, the scissor consists of two levers, not of one lever, because there are two parts of the scissor. This is the first kind of lever. Now we are talking about the second kind of lever. In second kind of lever, the weight lies between the fulcrum and effort. Look at here. This is another figure. Look at here. Fulcrum is the one side. Right now, effort is between the fulcrum and the effort. Over here, it can rotate about here. Rotate about this point. This is called the fulcrum. This rigid bar can rotate in this way, and maybe clockwise or maybe anti-clockwise. This is the weight and this is the effort we are applying here. Effort we are applying here, and it is lifting the weight between the mid of the bar. Now, real examples of the second kind of lever. Nutcracker, you are applying the force on the end. weight is lifted between the nutcracker and it can rotate on other side. It can rotate about other side. Punching machine is also the example of the second kind of lever, punching machine. And the door. Door is also the examples of the second kind of lever. For example, door, it is rotating in this way. This is the fulcrum. Rotate. Suppose that this is not a book. Suppose that this is the door. So it is rotating in this way. It means that this is the fulcrum. Weight, you are applying the effort over here, or this is the weight. This is the weight. This is the second kind of lever. In the second kind of lever, the weight lies between the effort and the fulcrum. Now, third kind of lever. In third kind of lever, the effort lies between the fulcrum and the weight. Look at this picture again. This is a diagram over here. This is the fulcrum, about which this bar can rotate. This is the effort. Now effort is between the weight and the fulcrum. Look at here. This is the weight. You are applying the force. You are applying the effort in the mid on the lever, and it is lifting the weight on the end side. It means that in the third kind of lever, effort lies between the fulcrum and the weight. Now, the real example of the third kind of lever is a pair of forceps, human arm, and a file cam. Human arm, look at here, it can rotate here. This is the fulcrum. Effort is applying over here. Effort is applying between here, and it can lift the weight. So there are three kind of lever. Now this is the lecture is uploaded on your web portal. Now it's your duty to study it and learn it properly. And don't waste your time again in the physical class when I meet you. So I will take the oral test of all the terms. Thank you so much. Take care. Allah Hafiz.